Hi everybody, Jim Martindale with Cursebuster on the roll again this morning. We really appreciate all the support with the sharing and viewing of our walk around of our 20-foot Cursebuster. And we want to do a little bit of a sequel or a little more detail on the roller assembly. Been a lot of questions about that and curiosity about that. Really looks neat and unique, but we could stand to learn more about how it actually is put together and is it really reliable. And so this morning we're going to take it apart right down to the smallest detail so you can see the complete design laid out for you. And if we'll start by saying that we have departed from using a deep groove ball bearing, which actually was imported, engineered by a German company and of course produced in China. This bearing is a domestic bearing, who knows where it's made, but instead of using a deep groove ball bearing, we are now using a tapered roller bearing. Obviously, in many ways superior in the standard in terms of a combination of radial and thrust load bearing capabilities. And there's a pair of these in each end of the roller assembly. This end piece that you saw here in the previous video contains two of these bearings, a cassette seal, and also has a cap, a grease cap inside, and all of these elements are contained inside of the roller itself. So there's no way that precipitation, pressure washing, wind, rain, anything can get inside to contaminate the bearing. And as I indicated in our previous video, we tested these for 6 years in some rocks in Wisconsin, and today they still turn just like the day they were installed. No greasing, no servicing, no tensioning, no tightening, just ready to go. So today, what we're going to do is we're going to actually show you how it is assembled, disassembled, so that if you're ever provoked to add some grease to the bearings, you'll see how it goes together and how you could service it if you desire to do that. So first, the element that there's one of the points on this hub which indicates that this is where you would level check. If you were to use gear oil, for example, and you wanted to check the level of gear oil, this is where you would do it, because inside here there is a port which contains a pipe thread, and it has a pipe plug in it, and that's how the bearing is actually filled upon assembly in our assembly operations. The ability to remove this basically requires an Allen. The nut is inserted in the casting so it holds itself. You basically are going to take out this bolt, and then you'll have access to another bolt which is only really there to set the helical pattern or the position of the tine on the pipe. This bolt right here screws into another part which we'll look at here in just a minute. Once this other transverse bolt is removed, now you can remove this bolt, which, as I said, sets the helical pattern for the rest of all the tines. So we're going to back this out, and in tine changing, you don't even have to remove this bolt. All you do is loosen it to the point where the tine can be removed. But we'll touch on that a little bit here. So this bolt comes out, and then inside with this Allen wrench we'll loosen the pipe plug which seals the hub. Well, I dropped that before this morning. So this is our pipe plug, and then we insert our extension for our Zerk fitting. And there we go, ready to grease. And it probably would take very little if you decide to do this. If you over-grease, you'll actually push a vent out of the grease cap because it has a vent hole in it so that we can totally fill the bearing. It is completely packed. There is virtually no air left inside the hub where the bearings are located. So if you overgrease, you have the potential of pushing the vented cap plug like you would see on a semi-trailer axle with 90 weight gear oil, wet hubs. So that's basically how this all goes together. And what you're looking at is kind of Gen 1, I guess you would say, on how we held the tines. We had a bit of an issue, a little bit of history in our first run up with these, and so we have actually made a very big improvement, I think. The roller itself has been relatively service-free, but we're going to make it to the next step. And for that, we'll slip down here and we'll take a look at the latest and the way in which we're modifying our system. As you can see from the tine, there's been a machining operation in the base of the tine. This is so that it can accommodate a flange-headed hex bolt, half-inch bolt, grade 8, in that position. Now, the reason this is being done is because these two bolts, these two half-inch bolts, are going to secure this element inside of the pipe. This is kind of a mock-up, but it sits in between, of course, the base of the tine and this tab. This tab now inside the pipe becomes the holding device for the tine to stay on the surface of the pipe. This baby sits in here, making sure that the tine stays in the right position. And there you have it. The next tine, adjacent tine, comes in here, and this bolt will hold that one. When you actually change these tines, what you'll do is loosen these bolts after removing the transverse bolt, not taking them out. Remove two bolts here. The tine immediately comes off. Place the replacement tine in, re-bolt, and keep moving around the circle, one tine at a time, removing two bolts and two bolts one at a time. That way you'll never lose the registration of these parts inside of the pipe. So there, basically, is what we're up to at Cursebuster, trying to make this thing more user-friendly, more dependable, less service time, less downtime, et cetera, et cetera. We're really excited about the reports we're getting from people about how the machine is working, and we want everybody to enjoy it once they buy one. And with that, again, soilcursebuster.com is the website. You've got my number at 260-706-3133. Love to talk to you, answer any questions that I may have created inadvertently in this. Hopefully this helps in understanding some of the intricacies of the construction of the machine. Thanks for being with us.